Hey folks, welcome back. We are going to be looking at a single sample t-test in this screencast, and what that is, in a nutshell, is it takes the mean of a variable that you've identified in your sample, and so you've run basically descriptive statistics and you've generated a mean number, and it asks whether or not that mean is statistically different than some other number that you have provided for comparison. And I understand that that's pretty abstract, so let's make it real. And what we're going to do in this particular exercise is we're going to compare, and here I go up to analyze, and I'm going to come down to compare means. I'm going to do a one sample t-test, and what I'm going to do is I'm going to compare the percentage of male respondents in the sample with what an expected number for males in the sample might be. And given that this is a sample of the U.S. population as a whole, we would expect that approximately 50% of the sample would be male and 50% should be female. And earlier in recoding the data in the data set, I created a variable that identified respondents who were male, and that varies from 0 to 1. And so when we run the mean of this variable, if we were anticipating to find that 50% of our sample was male, we would expect this to return a value of 0.5, meaning half the respondents were 1 and the other half were 0. And so to test whether or not 50% of our sample is in fact male, I'm going to go ahead and put 0.5 in here. And up here I've got the options if I want to run a confidence interval around this. If I wanted to see what 99 out of 100 times running the statistic would produce, I'd do 99. But the sample, or rather the standard of 95% is the norm, and so we're going to go ahead and leave that there. Again, just to emphasize, what I'm doing here is I'm going to look at the percentage of male respondents in the data set, and I'm going to compare that with the expected value of 0.5. Because we are running an analysis here and we're not changing our data in any way, we're going to go ahead and just do the point and click option rather than trying to paste into syntax. And I do that, and I've got my t-test running. And what the t-test does as the first procedure is it runs a descriptive statistics to create the mean. And what we see here is the male respondent, the average response was 0.5439. Again, we expected half of our sample to be 1 male, and we expected the other half to be 0 for female. And what we've got with 0.54 is that means that about 54.4% of the sample was male. Now, the question that the statistic allows us to by running the t-test to examine is whether or not that 54% in our sample is due to random chance, the normal sampling error that you would expect, or is in fact there are more males in the sample than one would statistically anticipate, suggesting that there was probably something that was just a little off in drawing the sample. And as we go down to the t-test here, we're comparing our 54% versus a test value here, right where the pointer is, of 0.5, and what we find is that there is a statistically significant difference. And in fact, what this significant two-tailed test is telling us is that 999 times out of 1,000, if we were to run, if we were to go out and to sample the population, if you got a sample that said you had, looking at 1,504 people, you'd expect almost every time to find that more of your sample was male than should be. And what that means is that this 54.39 statistic is in fact statistically different than 0.5. Put in practical terms, what this tells us is we can say with almost complete confidence that there are more males in that sample than there should be. And that means if we were going to go ahead and do some type of sophisticated analysis, we'd probably want to turn on the data weights, which Pew provides and many organizations do for us. The way that this sample is often used is, or rather this test is used, is to look at the difference between your mean and some particular value of interest. In this particular case, it was, is the sample truly 50% or not? One could imagine a sample in which respondents were asked to rate presidential candidates on a 0 to 100, and let's say that you're looking at one particular candidate and you find that the average rating that was given to that particular person was, let's say it's 54 points out of 100, you might ask yourself, is this statistically different then 50 points. And again, if we went back and we did the analyze and we did the t-test and we went all the way down there, in that case our point of comparison, the test value that we would be looking at would be 50 because the original variable went from 1 to 100, and in the example that I've just given we would be testing whether or not, say, 54% was in fact different than 50%, such that you could say that the average respondent in the sample gave the that particular candidate a positive versus a neutral or negative evaluation rate. And that, my friends, is what a single sample t-test does.